All right, so let's do the last part of the Winnow convergence bound. So we're trying to prove this theorem here. And so far in the other videos, in the first couple parts, we've shown that this difference, this improvement from one step to the next, looks like this. Okay, so this step was proven in a previous video, and then we had another step proven in the second. This is like, the step 1 video, and then this one is the step 2 video, which is that the negative log of z is greater than or equal to this term over here, log e to the eta plus e to the negative eta divided by 2. Okay, and the interesting thing, of course, is that this guy is actually the same as this lovely denominator right there in the theorem. Okay, so we're going to call that thing, this is definition. Okay, we're going to define that to be called that guy. Okay, delta. All right, so we know that this difference in the phi's, which is actually called relative entropy, that we know that this relative entropy decreases by at least that guy at each time. Okay, so the next step, we know that this is the improvement at each time, so I can add up all the improvements and get the total amount that it has improved over the course of iterations. Okay, so this is a telescoping sum. Okay, so we'll put it in here. And this thing then is greater than t times that guy, right? Because this is the improvement at every iteration, and we've had t iterations. And this is the lower bound. Okay, so the next step is actually to create an upper bound. So this is a lower bound. And then we'll create an upper bound. Okay, so the upper bound is, I'm going to look at this guy again. Greater than or equal to, now guess what? This guy, KL divergence, is always non-negative. So this guy, less than or equal to that. Okay, and then by its definition, it's the same thing as that. Okay, and then again by definition, log of Wj star is a definition again of KL divergence. And then of course W0, I don't know if you remember it, but it's just uniformly 1 over p, okay, where p is the number of features. Okay, so then I can rewrite this thing as being log of p times Wj star. Now, again, remember that W star is, just remember it's a discrete probability distribution. And so its values are between 0 and 1. Okay, so we'll just write this like this. Log of p times 1, right? 1, you can always upper bound this by 1. It's completely fair because of that. And then, of course, I can pull out the log of p. I can just pull that right out. And guess what I've got left? And brilliantly, that thing is 1, because again, Wj is a discrete probability distribution. So this thing then equals just plain old log of p. Whoop, log of p. Okay, so finally I have this is the upper bound. Use the upper bound. Okay, so we have the lower bound on that thing is less than the upper bound on that thing. Okay, and thus t is less than or equal to log p over that. And that, my friends, is the end of the proof.